Hi, very good morning. Today we are going to talk about the feedback amplifiers. Feedback amplifiers, basically there are like two types. One is positive feedback, other one is negative feedback. When we are using the positive feedback, we will create the oscillators. Oscillators are the one that's going to be the heart of any electronic device, because unless we create oscillations we can't create timing. If we are not able to create the timing, we cannot have the synchronization between the events that happens inside every electronic device. Next one is the negative feedback. Now when I say negative feedback, what we are going to do is we are going to take a part of the output, and via the feedback network we are going to feed that to the input. So this is the basic thing. Now we are going to see how we are going to design a feedback amplifier, like what are all the varieties we have and what are all their advantages, disadvantages. This is what we are going to discuss here. Now let's go into it. So now we'll discuss the voltage series feedback amplifiers. Now what we are doing here is, see, this is basically an amplifier. Now I'm giving the source voltage as Vs, and what I get here after this thing is the input voltage is Vn, right? So that is getting amplified by A times. And as you know, this is a voltage series feedback amplifier. It's basically a voltage amplifier, though resistance, the output resistance is in series here, and this is what is the load resistance. Now what we are doing in the feedback is, you see that the magenta color line, so this is what is the feedback. We are taking the output and feeding it back to the input. Now if I write KVL to this loop, KVL to the input loop, so here Vs value is equal to Vin plus Vf, right? So now what are all the things that we have to see? Say, let me say, I'll say that AF is the uh, closed loop gain, A is the open loop gain, beta is the feedback, RIF is the input impedance, with feedback, ROF output impedance with feedback. Now what we'll do is, and again we all know that the gain is always output by input, right? So I'll use this and I'll write it as A is V out by Vn. In our case, generally, yeah, this is how it is, V out by Vn. Now AF value is going to be with the feedback. Now let's go deeper into it. So first part, what I'm going to do here is, I'll take this as that Vs value is equal to Vi plus Vf, right? Now what we'll do is, we'll go ahead and AF, that is overall gain, output V out divided by the source voltage. Now what I'll do is, I'll retain the V out as it is, and instead of Vs we have seen that it is Vi plus Vf. Now what I'll do is, I'll take the V out to the bottom, so I'll write it as, it's like 1 divided by V in by V out plus Vf by V out. Now what I have seen is, like 1 by V in by V out is like 1 by A, Vf by V out we have seen that is beta. So based on this I can write that AF value is equal to 1 by 1 plus A beta divided by A. Now I take it to this up, so it's going to be A by 1 plus A beta. So the feedback gain is A by 1 plus A beta for a voltage series feedback amplifier, right? So this content is available with us. Now next we are going to see the input impedance. Now when I talk about the input impedance, like what I'm going to see is I need this RIF value. So let us see how we are going to derive the RIF value. Now going ahead with this, the RIF value is Vs divided by II. Now Vs value we have just now got it as Vin plus Vf, right? So now what I'll do is I'll retain the Vin as it is. Instead of Vf, we know that the feedback is like that is like whatever the feedback that is beta is the parameter, so beta is like vf by v out. So now based on this I'll write vf is equal to beta times v out. So I'll use this here plus beta times v out, right? Now what is v out? Now v out value, if I say, that is the amplitude, I mean the amplification times Vi. So that's what is here, right? So amplification times Vi. So I'm using this here. So I'll write it as Vin plus beta into A times V in or Vi, right? Now once this is done, now what we are going to do is like we'll take this Vin parameter out of it. So it's going to be 1 plus A beta, that's like Vs. Now this value Vin, I'll write it as Ri into I. So how do I write it? So now if I check it, so this value, this is the Ri value and this is the II. So the voltage V I or V in is like Ri plus II into 1 plus A beta, that is equal to Vs. Now what I am interested is RIF. RIF is like Vs divided by uh, voltage divided by the current high. So that's going to be like yeah. So I'll take this to this I to this one. So what is left out is Ri into 1 plus A beta. So I see that the input impedance is getting increased by 1 plus A beta time, which is very much essential for a voltage amplifier. Next, we'll discuss regarding the output impedance. So when I say output impedance, what we are going to do as a basic thing, first what we'll do is we'll disconnect the load resistor and we will replace it with a voltage source. V, and again second step is like the source voltage Vs Vr will make it to 0. Now if I do the same thing to this part of the circuit, I'm going to do the same thing to this part of the circuit. Now I'll do this. So what happens here is I'll have A times V in, right? Then R out. What I'm doing here is I replace that RL and I'm going to introduce a voltage source here. Now for this, if I write the KVL to this loop, so it's going to be voltage E is equal to, let me say the current I is flowing through it, I times R naught, that's the current flowing through this, plus this is again the voltage, right? So I'll mark this one positive negative and then positive negative and this also positive negative. So plus A into Vn, right? Now based on this I'll write I is equal to V minus A times V in divided by R naught, right? Now what we have done here, see, I know that Vs value is equal to V in plus Vf, right? We have seen that. Now what did I do? I made Vs is equal to 0, so this becomes 0. So Vn is equal V in this way. So Vn value is equal to minus Vf. So what is minus Vf? So minus Vf in my case here is it's beta times V naught, but anyway we are considering V here, so the B naught will be replaced by V. So it's going to be beta minus beta times V. Now I'll use this here. So I is equal to V minus A into minus beta V, right? So divided by R naught. So that we will write. So this is V plus A times beta V, that's equal to I by R naught. Now we'll take small modification, so I'll write it V into 1 plus beta by R naught is this value. Now what I'll do is I'm interested in getting the value of ROF. So ROF, that is like it's going to be like voltage by current, right? So now what I have here is the voltage and this side I have current. So if I do that, it is going to be Rout divided by 1 plus A beta. So we can see that the output impedance has decreased by 1 plus A beta time. So this is also one of the most important requirement for the voltage amplifier. Hope I have cleared this. So first AF value what we will get is A by 1 plus A beta. Then input impedance what we get is like Ri into 1 plus A beta, and then ROF is like R out divided by 1 plus A beta. So these are all the three important points of a voltage series feedback amplifier. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.